Hello, everyone. Welcome back to continue the answer of final revision sheet for semester 2. Let's begin with the first question in page 3. Find all point of inflection. Point of inflection, I'm talking about second verb. I have to use on the graph of this function. Okay, follow the steps. You have to remember the steps. I have to find the first derivative first, then the second derivative, because without the first derivative, we can't find the second derivative. It will be 3x squared minus 12. It will be here 6, that's right. Okay. Third step, when the second derivative equals 0. Here the domain, all real numbers. Okay, second derivative equals 0 when 6x equals 0, implies x equals 0. At x equals 0, maybe it is an inflection point, maybe no. To know that, I have to discuss the concavity. The function must be changed its concavity at x equals 0. Second derivative test here, 0. Here negative infinity and here infinity test value. I think that that's too easy. Sorry, 1 or 2 by any way. I think the easier one, negative 1, it will be negative. So the function is concave downwards. At 1, positive, okay, I have to replace here. Positive, the function concave upwards. At 0, the function change its concavity, second derivative equal 0, the function defined at t. So at 0 and f of 0, okay, is an inflection point. Inflection what? A point. Okay. 0 replaced in the f. If here f, it means the original function, it will be 0 and 0. That is why our choice is B. Okay. The next problem, clear the here. I give you the second derivative, like if x has critical number, okay, use the second derivative test to determine what which critical numbers, if any, give relative effect. I know the rule or the theorem. Is the second derivative at a critical number, okay, positive, so it will be relative minimum. Why? If it is positive, so the curve concave upward, so we have a relative minimum. If the second derivative at the critical number negative, it means the curve concave what? Downward. Downward, it means we have a relative max. You have to know in this test, second derivative, I have to find the critical number. But already it is given. Find the second derivative, already is given. So what is the third step? I have to substitute by the critical number in the second derivative. Look here, I have to find the critical number at this critical number. Second derivative at 0. Second derivative at critical number 1. Replace here, if we replace by negative 1 here, negative, and here positive, it will be positive, I think. Look here, negative 4 plus 2, it will be negative. Negative, so if it is negative, this function concave what? Downward. So we have a relative maximum at x equal negative 1. Okay. At 0, if you replace, it will be 0. In this case, if the second derivative equals 0, test fail. And in this case, we have to use the first derivative test, okay? At x equals 0. At 1, okay, you told me to use the second derivative test. At 1, it will be 4 minus 2, it will be 2, so the value, it will be positive. This means the curve concave upward. So we have what? Relative minimum at x equals what? -1. He asked you, please, at what one? Oh, I'm sorry, 1. He asked you to find the relative maximum at which one? A relative maximum here at x equals -1. Why? Our choice is part A. Okay. Don't forget the test. That is the test. To use the second derivative test, I have to substitute by the critical number. So it means I have to find the first derivative, find the critical number, find the second derivative. But here I gave you everything. I gave you the second derivative. I gave you the critical number. I need only to substitute by the critical number in the second derivative, then identify relative maximum, relative minimum, or the test stage. For the next problem, the third one is first in page 3. Let f of x power 3 minus x squared plus 3. Use the second derivative test. Here, use the second derivative test to determine what? Which critical numbers, if any, give relative extrema. It's too easy. I have to follow the steps. He told me I need critical number, second derivative. Okay. I have to find the first derivative to find from each the critical number and find the second. It could be 3x squared minus 2x. Okay. From this one implies to step 2, find the critical number. 3x squared minus 2x equals 0 implies x common factor, x minus 2 equals 0. Implies x equals 0 or 2 over 3. And I can use modify 3 to 5. Critical number. Okay, critical number. Third step, I have to find the second derivative. He told me I need the critical number. From where we get the critical number? From the first derivative. From where we get the second derivative? From the first derivative by applying the rule of differentiation. It would be 6x minus 2. Implies what? So, no, I don't need the inflection point. I need only to replace by these critical number in the second derivative. Find the second derivative in the substitute by the critical number in the second derivative at this critical number. Replace by 0 in the second derivative, it will be negative. So the curve of the function concave downward, we have relative maximum. At x equals 0. 2 over 3, it will be 4 minus 2, it will be 2, it will be positive. I have to replace here. I care about the sign, I don't care about the values. Positive, this means the curve concave upward. Upward, so we have relative what? Minimum. At x equals 2 over 3. That is why the answer x at x equals 0 relative maximum, at x equals 2/3 relative minimum. I think it's too easy. Just apply the rule. How to use the second derivative test? Just replace by the critical number in the second derivative. But from where we get the critical number? From the first derivative. From where we get the second derivative? From the first derivative. Okay, then replace by the critical number in the second derivative. Okay, let's continue here. Identify the choice that best completes the statement or answers the question. Here, you have to revise well the rules of the integration. That is the constant rule of integration, as you know. That's right. That's right. Okay. Look here. That is definite integral. How we find the definite integral? I have to find the integration of this function. What is the integration of 4? It will be 4x. That is the constant rule. The integration of any constant with respect to any variable from a to b, it will be kx. That is the integration of this one. Okay, then substitute to find the difference between the value of the antiderivative at the upper limit minus the value at the lower. That is from what to what? From -3 to 7. So it will be just replace 7 multiply 4 minus 4 multiply what? -. Okay, it will be what? 28 plus 12. It will be 40. That is why our choice is D. Okay, for this one, by the same way, I have to find the antiderivative. All of you just apply the rule of integration. Okay, it will be what? How to integrate this one? I can find the integration here at the right. It will be -2x power 2 over 2 plus 4x. To simplify it first, it will be -x squared plus 4x. Don't forget the rule of the power rule of integration. X to power n with respect to x. It will be x to power n plus 1 over n plus 1 plus constant. That is in the case we have this constant in indefinite, but indefinite, in the case of definite integration, we don't have this constant. Okay, what is the antiderivative here? It should be -x to power 2 plus 4, -4 to I have to find the antiderivative at 2. It should be what? Find the value here minus the value of the antiderivative at the lower limit. It will be -2 square plus 4 multiplied. Here it will be what? -4 power 2 plus 4 multiplied. So it will be here. What is the answer here? It will be -4 plus 8. It will be 4. You can find the answer by using that. Minus this one, it will be what? Negative here, and here it will be what? Don't forget substitute between two brackets. This one, it will be 16, -16. Here a -16. It will be negative. It will be -32 minus -32. So it will be 4 plus 32. You can use the calculator to find it. 36. That is why our choice is the D. Just apply the rule of integration. Okay. Look here, how to find this one. Yes, I think it's so easy. 6. Okay. X. That is the antiderivative. Add 1. It will be 6 to power what? Over 6. Add 1 to the exponent, then divide by the new. From what to what? -3 to 5. That is the definite. How we find? I use this fundamental theorem of calculus. Fundamental what? Theorem. It will be this one constant. It will be 6 to power x to power 6 from -3 to 5. Okay. Here it will be 5 to power 6 minus -3, okay, to power 6. Okay, wait a minute. So your answer, it will be 15,896. That is our choice. 15,890. Okay, by the same way, just apply the rule. That is the definite integration. I find the value of this definite integration by using fundamental what? Theorem of calculus. Please revise well. Look here, I just apply the rule of integration. No more. Okay, look here, this function, to find the integration of this function, that is what? Indefinite. I have seen. Okay, indefinite. But in the case of definite integral, I don't have. Means I can find the integration without rewriting this function. It will be what? The integration. Since I rewrite the function, I keep the integral symbol with me. It will be -24 x to power -7 can apply the rule of the integration, which will be constant, this constant 24. Then add 1 to the exponent, it will be negative 6 divided by the new exponent, okay, plus constant. I need to rewrite this function to be in the simplest form. This one, it will be 4. It will be what? 4x to the power negative 6 plus 3. But don't keep it with negative exponent. Just move it to be in the denominator. It will be 4 over x to the power 6 plus constant. What is the answer for over x? This one. Our choice is C. Okay. Sometimes I can't apply the rule of integration directly. I need to rewrite the function to be ready for the integration as you see. This one, no, I just apply the rule that is indefinite. Indefinite, I have C. Okay, constant C. Okay, here it will be 7, x to the power, add 1, apply the rule, the power rule of integration. I add 1 to the exponent, then divide by the new exponent plus constant. It will be plus negative 3 over negative 3. Okay, what is the integration here? Or by another way, what is the function whose derivative cosec square x, which is what? Tan, cotan. But here cotan. But since it has particle, okay, I write negative. Plus constant. Plus what? Constant. Which one? Negative 7 over x power negative 3 minus. Yes, that is why our choice is D. I hope you understand. Look, I know the derivative of cotan x. With respect to x, it will be negative cosec square x. Here, so the derivative of cotan cosec square, negative cosec square. When we find the integration, what is the function whose derivative cosec squared x, it will be negative cotan x. Since the integration of the function has a particle, so we have negative sign. Just apply the rule. Just apply the rule of the integration. Let's solve the last one in this page. Okay. Look here. Wait, sorry. Apply the rule of integration. Just apply. Here, add 1, number multiply function. It will be this number, multiply the integration of this function. It will be to the power 3, add 1, 3 over 3. Negative 9, multiply the integration of sine t. Sine t, it will be cosine, but it has 2, it will be negative. Cosine t plus constant. Rewrite to be in the sum form over 3 plus 9 cosine t plus constant. Don't forget the integration of sine negative cosine. Negative what? Cosine. So it will be 2/3 to the power 3 plus 9 cosine t plus t. So what is the correct answer? This one. It is wrong because the integration of sine t negative cosine. Negative, negative, it will be minus negative, it will be plus. I hope it's so easy for you. Okay. For this one, I just apply the properties of integration, definite integration. Look here, I remind you by the rule, when we find the integration of any function f of x from a to a, f of x, sorry, with respect to x, I'm sorry, it is 0. So that is the choice. It is for any function, yes, any function. If the upper limit as the lower limit, it's the answer 0. Please revise the properties of a definite integral. Here, the integration that is indefinite, but here's definite. Indefinite integration secant square x with respect to it means what is the function whose derivative? Whose derivative secant square? I know it is tan x plus constant of the integration. That is why our choice is A. I think it's so easy. For this one, suppose that the definite integral of function f of x with respect to x from 1 to 3, 1. Find the definite integral from 6 to 6 of f of x with respect to x, and from 3 to 1, the definite integral of the function f of x from 3 to 1 with respect to x. I know, just apply the rule. Apply the, not the rule, the property. The definite integral of any function whose upper limit as the lower limit 0. Here, how we get the definite integral of this function from 3 to 1, which I just switch the upper limit with the lower limit in the given function, so it will be -1. I know the definite integral from b to a f of x, it is negative, the switch of this function from a, the switch of the upper limit, f of x with respect to x, and here. The definite integral, if you switch the upper limit with the lower limit, so the value of the integration will be negative the integration before switching the upper with the lower. It will be d. Okay. For this function, just apply the rule. Just apply the rule of the definite integral. Look here. This is so easy. I give you the definite integral of a function f of x from 6 to 10. It is what? -5. That is given. The definite integral of function g of x with respect to x from 6 to 10 is 7. Find the definite integral of this function. It means this one I know the definite integral, the first function, minus 2 multiply the definite. It means the definite integral from 6 to 10. But sometimes I don't need to rewrite this one because I know the property. Number multiply function, it will be this number multiply the integration of this function from 6 to 10 with respect to it. I know what is this value, it is given already, -5. This one, it will be -2. Multiply the definite integral, which is given 7. 2 multiply 7, so it will be -19. That is why our child is -19. I think so. Just apply the rule. I know the definite integral of a sum of two functions or difference will be the definite integral of first minus the definite integral of second, or the definite integral of first plus the definite integral of this second. Please revise the properties of the definite integral as I explained before in the recorded session. Okay. Sorry, let's solve the last one in page 5. Okay. Here it is definite or indefinite. Here, indefinite since I don't have upper or lower limit. Just apply the rule. Look here, the definite integral of any constant multiply function, it will be this constant multiply the indefinite integral of this function with respect to. Okay. The integral of the integration of x power n with respect to x, it will be x to power n plus 1 over n plus 1 plus constant. Look here, it will be this number 3, multiply the integration of this one, apply the power rule, it will be 4 over 4. Minus 10, multiply the integration of this one, it will be x to power 2, add 1, then divide by the limit. Plus the constant rule, I know the integration of any constant, it will be this constant multiply the variable of the integration, the constant of the integration before. Okay. To rewrite it in the sum form, we just simplify this 5 to 0 over 5 minus 5x squared plus 4x plus 3. That's all. Thank you for joining this session. Okay, bye-bye.